looking at a definite integral with trig. So the definite integrals of trig are basically the antiderivatives in reverse. So they're the antiderivatives in reverse. So what you're going to do is, if it's sine, then it becomes cosine. If it's cosine, it becomes sine. And then you have to also be cautious of the signs. So in the past, when you took the derivative of a function that starts with c, its derivative had a negative. Now, if you take an antiderivative and the answer has a c in it, then it becomes negative. So let's look at and discuss those two problems down at the bottom. Eek. So the first one is negative cosine x. So what I would do for this problem is essentially say, okay, where is negative cosine x? Well, that's kind of like the same as bringing out a negative 1. So I have pi to 2 pi of cosine x dx. And then what I'm going to do from there is find the antiderivative. So the antiderivative of cosine is sine. So this becomes negative 1 sine x evaluated from 2 pi to pi. And then what we do from here is keep the negative 1 out in front. Take the sine of 2 pi minus the sine of pi. And we get negative 1. The sine of 2 pi is 0. The sine of pi is 0. Negative 1 times 0 is 0. Okay. Looking at the next example. So we have this time 9 sine x dx. So once again, I'm going to factor or remove the constant and bring it out in front. I do this so that I can just look at the antiderivative of sine as opposed to looking at the other value. So then you have from 11 pi halves to 6 pi of sine x dx. So then we get 9 times negative cosine x evaluated from 6 pi to 11 pi over 2, which is really negative 9 cosine 6 pi minus a minus, so a positive 9 cosine 11 pi all over 2. So that's negative 9. The cosine of 6 pi is positive 1. Because really that's like subtracting 2 pi, like subtracting 2 pi, and that gets you to 2 pi. So what that means is on the unit circle value, that's really like the cosine of 2 pi. And 11 pi over 2, well, you could subtract 2 pi from that, which is really like subtracting 4 pi over 2 to keep the units matching. So you'd have to do
that twice, so that's like subtracting 8. So this is really the equivalent of 3 pi halves.
And the cosine
of 3 pi halves is 0.
So you get
plus 9 times 0, or negative 9. Yep. Yeah, so the 2 pi is how you get back to the unit circle. So yeah, so you stop once you get to a value that's on the unit circle so that you can evaluate it. Yep. All right. So that sort of transitions us out of the trig stuff. I believe on Friday we have left off maybe with a couple of examples in our notes that were like the natural logs. So we had a couple more examples at the top of that back page. So if you recall, we said that the antiderivative of 1 over x was a special antiderivative. So if you recall that 1 over x is a special antiderivative, it is the natural log. So that became the natural log of x from 5 to 1. And that became the natural log of 5 minus the natural log of 1. And we said that that was equivalent to the natural log of 5 because the natural log of 1 is 0. So that same idea and concept will happen for a function like number 6, where we have 1 over x plus 2. So that still represents a natural log. So this is the natural log of x plus 2. And for antiderivatives, when you go from the function to the natural log, you have to put absolute values on it. This is from Friday. It was in your notes packet from Friday. It's like the very, very last page. Okay. So if you take an antiderivative of a natural log, it has to get the absolute values, because you cannot take the natural log of a negative. So you're evaluating that from 5 to 1. So the rule is f of a minus f of b. So it's like the natural log of 7 minus the natural log of 3. And you can leave it like that, or you can also write it as a singular fraction, because if you recall our natural log rules, the natural log of 7 minus the natural log of 3 is the same as the natural log of 7 divided by 3, because the subtraction of 2 natural logs is equal to their division. You could also check this on the graphing calculator. So you could go to your Math 9 and you could type in your, so again I was trying to show you here how the minus and the division are the same. And then here you can check the 1 to 5 and do 1 over x plus 2 dx. And again, it's going to give you that decimal form. It's not going to give you the natural log form.
So that's part of the other reason why it's so important to know how to do these by hand. Because even if this was a calculator test question on the AP exam, I can guarantee you their answer would be this, not that. However, you could take the comparison of the two, so you could use your calculator, get this, and then compare all the multiple choice answers, time consuming, but would get you there. Okay, if you think back, and we're going to do this a little bit more in-depthly in a few days, but here we have 2x on top and x squared on bottom. This is actually still a natural log, because if you think about the derivative of the natural log of u, its derivative became 1 over u times u prime. So you can kind of see here, this antiderivative is the 1 over u and u prime. So that means that this is really like the natural log of x squared plus 1. From 1 to 0. Or the natural log of 2 minus the natural log of 0. And the natural log of 0 is not in our domain. So this would represent an integral that is not continuous. This would represent an integral that is not continuous, because 0 is not in the domain of the natural log. Oops, just kidding. That should be a natural log of 1. It's 0 squared plus 1. If it was 0, though, it would not be in our domain. Sorry. 0 squared plus 1 is 1, not 0. Natural log of 1 is 0, though, making my answer the natural log of 2. But once again, if you would get something on an integral that is not continuous, it is not integratable. Number 8, another example of a natural log. Now for this one, this 2 is kind of like a constant factored out in front, because it wouldn't be part of my antiderivative. So that 2 is kind of like a factor out in front. Because if you think about the derivative of natural log of u, it's 1 over u times u prime. Well, u prime of x plus 3 would be 1. So that 2 is kind of like a constant we would bring out in front. So my integral would look more like this, thus making it 2. And you find your antiderivative from 5 to negative 1. So we get 2 natural log of 8 minus the natural log of negative 1 plus 3, which is 2. So natural log of 8 minus natural log of 2 is really ln 8 divided by 2, or 2 natural log 4. Okay, and number 9. Well, number 9 is to be continued. Why is number 9 not a natural log? Why is number 9 not, Maddie? Exactly. We need an x up top in order for it to get an ln. We can't take x to the negative 2 up. So it's just important to be able to recognize where you can and cannot go. Number 9 is a to be continued, and honestly, this year, we don't have to do number 9, because that is a CHS question, and we don't have to do arctan. So just in case you want to know, that's an antiderivative of an arctan. If you think about this, you can almost see the derivative. If you think about the derivative of inverse tan, it was u prime over 1 plus u squared. So you can see the arctan up in there. But arctan, if there is one, there's usually only ever one. So I'll go back through, but I believe they pulled that from the AP exam this year. So that would be an arctan, but I believe it's pulled from AP this year. Okay. So what I want to do is use time today in class to work on 5.1 and 5.3 sort of review questions. So we've been focusing a lot recently on antiderivatives and being able to find them, working through them, etc. So you don't have a test or anything big tomorrow. If anything, I might just give you like 5 questions to start class that are either multiple choice or like 3 multiple choice and 1 open-ended. I haven't decided, but I'm not wasting, I can tell you right now, I'm not using tomorrow for a whole test day. I also can't give you back your test until the student that hasn't taken it takes it for me. So we have to, and that's another reason why I don't want to give you a quiz before we've flipped over our quiz, even though this is totally different from that. I don't want to put that student in a position either where they still owe me and owe me another one. So we're going to use today as a review day. So I want you to start with the 5.1 AP questions. I want you to work on these 7 questions until the bell rings. When the bell rings, you may take your break with the school. And then when you come back, we'll go over and talk about these AP questions. So use like the next 5 minutes, 4 minutes, whatever it is till that bell rings to start 1, 2, and 3. You should be able to get through those 3. On calculator, it is a Riemann sum. So it is a right Riemann sum. So that means when you're setting up your table of values, you have your first box, your second box, and your third box. So then it told you to use the table of values, and then it wanted you to create an approximation. So the distance from 4 to 7 was 3, 7 to 12 was 5, and 12 to 15 was 3. So when you did a right Riemann sum, your first width was 3, and your height was 7. 7, geez Louise. 6.2, because you would pick the value at 7. And then you would do 5 at 5.9 and 3 at 5.6. And then you would have to multiply this together. So 3 times 6 is 18. So that's like 18. And then 3 times 0.2 would be 0.6. So you could just kind of break them with your decimals into 2 different parts of the row. Don't try to take 6.2 times 3. Take 3 times 6 and take 0.2 times 3. So that's 18.6. And then for 5, it'd be 5 times 5 is 25. 5 times 9 is 45. So 5 times 0.9 would be 4.5. And 3 times 5 is 15. And 3 times 6.6 would be 1.8. So now when you add those all together, you add, 18, 25, 4.5, 15. Again, like if I'm picking numbers to add, I'm going 15 and 25 together to start, because that's going to give me 40. Then I'd add my 18 to get me to 58. And then I would probably look at the rest of the numbers and just sort of add them up slowly and get to 64.9. And that represents liters, because liters per hour times hours leaves you with liters. But it says I started with 50 liters. So you had to add 50 back to that. So 64.9 plus 50 got me to 114.9. So anybody that picked A got that wrong. Okay, number two. Number 2 is a geometric summation. So number 2 is a geometric summation. And your answer was D. The answer for number 2 was D. And then number 3. I think we all did pretty well on number 3. So number 3 said, if it goes from 1 to 10, and f of x is 4, and then 10 to 3 is 7, what is 1 to 3? So what you had to do was take 1 to 10 minus 10 to 3, so that your answer was 1 to 3, or so that you had 4 minus 7, which was negative 3, or choice A. If you got to number 4, number 4 was also, I believe, choice A. Okay. And then number 5, if it goes from 30 to 100 is equal to A, and 50 to 100 is equal to B, 30 to 50 is equal to, so again, same idea, you would go 30 to 100 minus, and you're going to make the 100 match, so it would be 100 to 50. So it would be 30 to 100 minus 100 to 50. And that would get you to 30 to 50. So that would be A minus B, which is choice B. Number 4, if h of x is an odd function, so an odd function means it's symmetric about the origin. It also means if your original graph has x, y, then it contains the point negative, so negative x, negative y would be your first reflection, and then the second. So if it contains or gives you that 3 to 5 of h of x is negative 2, and you want to know negative 3 to 5, then that's kind of like saying, okay, what's happening from negative 3 to 3? Like we need to know what is happening from negative 3 to 3 of h of x dx. If it's symmetric, think about any graph that would be symmetric. So from here to here, here's your negative 3, here's your 3. So an odd function is symmetric about the origin. So that function is symmetric about the origin. That function is symmetric about the origin. What do you know about the area above and the area below from negative 3 to 3 for each of those graphs? What would the area of any odd function be if it's symmetric about the origin? What? I just can't hear. Yes. But I thought you said 4, and I was like, 4? I was like, so yes, whatever is below is above. So that means if you add those areas together, they're always going to equal 0. So this question mark becomes a 0. Because whatever is above is also below if it's symmetric about the origin. So that means that since we are missing negative 3 to 3, but it's 0, the area from negative 3 to 5 is equal to the original, which is 2. What? And 7, if f and g are continuous for all real numbers x and a is less than b, which of the following must be true? Well, from a to b of f of x dx is greater than or equal to 0. If the function is always equal to 0, then the area has to be equal to a number greater than or equal to 0. So 1 is true. So we automatically eliminate B and D. So now you're down to like 33% shot of getting this correct. The integral from a to b of f of x minus g of x is equal to the integral from a to b of f of x plus g of x. Would the signs in there change? No. Yes, maybe. Yes. So, that is true, right? Because what did we get pointed out? This also changed. So it's really important to pay attention. So what's changing in 3? Can I take a cube of a function inside and write it on the outside of my integral? Do we have that as a rule? No. The only thing we can take on the inside and bring to the outside is a constant. So what I want us to do for tonight is that next review packet. Tomorrow when you come in, we'll go over that review packet. So I'll have you submit it by 8:30. We'll go over that. And take a little mini quiz, and then we'll start 5-4, which is the general derivative. So I haven't decided if your mini quiz is going to be, it might be electronic, I might make it on like quizzes or AP Classroom, or even have to go formative. That way, since it's going to be multiple choice, you can kind of get your instant feedback. Let's just do, because there's a lot. Let's do the, oh no, look at the review. So let's do 1. We'll do 2A and 2D. So do 1, 2A, 2D. And then 3, that's just making sure you can use your calculator. So 3A is fine. 4, I like 4. There definitely is going to be stuff like 4 tomorrow. And for 5, you have to do 5 of the 7. I don't care what 5 you pick, you gotta do 5 of the 7. So 5 for 5 on the back. So it's 1, 2A, and D, 3A, 4, and then 5 and 5 of the 7.